Have you ever wondered where the universe came from? How did everything around us, from stars and galaxies to planets and people, come to be? The answer, many scientists believe, lies in an event called the Big Bang. This theory suggests that the universe began as a tiny, incredibly hot and dense point, and then expanded rapidly outward. This expansion continues even today, billions of years later. The Big Bang theory isn't about an explosion in space like fireworks on the 4th of July. Instead, it describes the expansion of space itself. Imagine a balloon with dots drawn on it. As you inflate the balloon, the dots move farther apart, just like galaxies in our expanding universe. This model helps us visualize how everything in the universe is moving away from everything else. The Big Bang theory is the prevailing cosmological model for the universe. It is supported by a wealth of evidence, including the redshift of distant galaxies, the cosmic microwave background radiation, and the abundance of light elements. This theory is the foundation upon which our understanding of the universe's history and evolution is built. Now let's rewind the cosmic clock to the very beginning. Imagine a point so small and dense that it's impossible to comprehend. This point, called a singularity, contained all the matter and energy that would eventually become our universe. Then, approximately 13.8 billion years ago, something incredible happened. This singularity began to expand rapidly in a process we call the Big Bang. In the first fraction of a second after the Big Bang, the universe was unimaginably hot and dense. As it expanded, it cooled, allowing energy to convert into fundamental particles like quarks, electrons, and neutrinos. These particles interacted with each other, forming protons and neutrons, the building blocks of atoms. Over vast stretches of time, these particles came together under the force of gravity, forming the first stars and galaxies. The expansion of the universe wasn't a one-time event. It's still happening today. We know this because distant galaxies are moving away from us, and the farther away they are, the faster they're receding. This observation, known as Hubble's law, is a key piece of evidence supporting the Big Bang theory. It's like dots on that expanding balloon. As the balloon inflates, the dots move apart. One of the most compelling pieces of evidence for the Big Bang is the cosmic microwave background radiation, or CMB. This faint afterglow of the Big Bang permeates the entire universe. It was discovered accidentally in 1964 by Arno Penzias and Robert Wilson, who initially thought their antenna was malfunctioning. The CMB is like a baby picture of the universe, providing us with a glimpse of what it looked like just 380,000 years after the Big Bang. Another key piece of evidence comes from the abundance of light elements like hydrogen and helium in the universe. The Big Bang theory predicts that these elements were formed in the first few minutes after the Big Bang, and their observed abundances match these predictions remarkably well. This agreement between theory and observation strengthens our confidence in the Big Bang model. The Big Bang theory also helps explain the formation of galaxies and the large-scale structure of the universe. According to the theory, tiny fluctuations in the early universe, amplified by gravity over billions of years, led to the formation of galaxies, clusters of galaxies, and vast cosmic voids. These structures continue to evolve today, driven by the ongoing expansion of the universe. The early universe was a truly exotic place, far different from the cosmos we observe today. Imagine a hot, dense soup of particles where temperatures were trillions of degrees and matter existed in a state unlike anything we experience on Earth. In this extreme environment, the four fundamental forces of nature, which govern the interactions of matter and energy, were unified into a single force. As the universe expanded and cooled, these forces began to separate. This separation had profound consequences, leading to the formation of the first particles, the emergence of light, and the creation of the elements that make up everything around us. The study of this early era is a frontier of modern cosmology, with scientists using particle accelerators and telescopes to recreate the conditions of the early universe and unravel its mysteries. The Big Bang theory has revolutionized our understanding of the universe, providing a framework for understanding its origin, evolution, and ultimate fate. While many questions remain unanswered, the Big Bang model has stood the test of time and continues to be refined and expanded upon by scientists around the world. It is a testament to the power of human curiosity and our quest to comprehend the vastness of the cosmos.